Hello sir, my name is Thomas George and my registration number will be 14-19 F1065 and I am from group H. Okay, the other members of my group will be Muhammad NURSHAHFIKRI bin SHAHZAM and his registration number will be 14-19 F1057 and the second member will be Muhammad KHALIF bin Hisham and his registration number will be 14-19 F1063 and last but not least ADLIN BINTI Yusri and her registration number will be 14-19 F1059. Okay, the topic that we are going to present today is about force vectors. Okay, let me start. We'll be talking about objective first. Okay, this experiment is mainly to verify the triangle construction or parallelogram law of vector addition by using force table. Okay, besides that, it is used to understand the basic concept of force vector, and this could be done by drawing a force vector diagram. Okay, the introduction and theory part. Okay, a study of motion will involve the introduction of a variety of quantities that are used to describe the physical world. For example, such as quantities include distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, work, and etc. All these quantities can be divided into two categories, which are called vectors and scalar. A vector quantity is a quantity that is mainly described using magnitude and direction. On the other hand, the scalar quantity is a quantity which is fully described as fully described by using magnitude. The emphasis of this unit is to understand some fundamentals about vectors and to apply the fundamentals in order to understand motion forces and forces that occur in two dimensions. Vector quantities are often represented by scaled vector diagrams. Vector diagrams are displayed a vector by using of an arrow diagram to scale in a specific direction. Vector diagrams were introduced by and used in earlier units to despite the forces acting upon an object. Such diagrams are commonly called as free body diagram. Thank you. And I will be passing to the next member.
Assalamualaikum. My name is Muhammad NURSHAHFIKRI bin SHAHZAM. My number metric is 14-19 F1057. Today I want to explain the lab for engineering mechanic. The title is force vector, and I want to explain the equipment and apparatus and their procedure. Okay, the equipment we use is force table, second pulley, third hanger, fourth weight, 5 string, 6 rings, and the 7 is the protector and ruler. And the apparatus like this, and then we collect all the equipment and set up the material like this paragraph. Okay, and then the procedure. First, we set up the apparatus and material as shown in the paragraph. Second, hanging the right weight for each angle given and circle the direction force and direction force value. Refer the table. Third, record the data at the result table below, and then calculate all the force acting on X and Y axis. And 5, repeat the experiment with data given on table 2. The last I can get is the assumption for the paragraph. I think the pulley are very frictionless and the string are very thin, so that the direction can be marked out accurately. The mass of the string is negligible. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURSHAHFIKRI from class 10 PKA. Today I would like to talk about the first vector experiment, and what I want to discuss about is result and calculation. Okay, this is for a table for a table 1. Okay, the symbol F1, the mass is 100 gram, and when converting to weight and force, it will be 0.981 Newton, and the angle 112. And for F2, the mass is 95 gram, and when converting to weight and force, F2, it will be 0.932 Newton, and the angle, it will be 244, and 240. To F3, the mass is 80 gram, and when I convert to weight and force, it will be 785 Newton, and for angle, doesn't got any angle. Okay, this is table 2. Okay, a symbol F1. Okay, mass is 88 gram, and when I convert to weight and force, okay, it will be F1. It will be 0.788 Newton, and the angle for F1 is 247. And to F2, the mass is 100 gram. When converting with weight and force, it will be 0.981 Newton, and the angle for F2 is 130. And to F3, the mass is at 90 gram, and when I convert to weight and force, it will be 0.883 Newton, and the angle for F3, okay, doesn't got any angle. Okay, this is a table 3, data analysis table 3, which is table 1. Okay, we know that F1 we get 0.981, and the directions to F1 is 190.99, and the magnetic force on axis Fx is negative 0.367, and the magnitude force on axis Fy for F1 is 0.909, and to F2 we get 932 Newton, and the directions we get 94.74, and the magnitude force on axis for F2 we get a negative 0.4 0.409, and the magnitude of force on X, we to F2 we get 0 cos negative 0.838, and to F3 we get a 0.785, and the directions doesn't got any directions. And magnitude force on x-axis for F3 we get 0.785, and magnitude force on axis Fy we get doesn't got any magnitude. And for all total magnitude force on x-axis Fx we get 0.0088, and for all total magnitude force on x-axis we get Fy 0.071. Okay, for table 4, which is table 2, okay, F1, and we know that we get 0.785, and the directions F1 we get 66.71, and the magnitude force F1 we get a negative cos 0.31, and the magnitude force F1 we get negative cos 0.72, and to F2 we got 0.9081, and the direction F2 we get 130.03, and the magnitude force on x-axis we get negative 0.63, and the magnitude force on x-axis Fy to F2 we get 0.75, and to F3 we get 0.883. Then the direction of F3 doesn't got any directions, and the magnitude force on x-axis we get to F3 we get 0.883, and the magnitude force on x-axis Fy we get doesn't got any magnitude, and the total of magnitude force is a negative 0.057, and the magnitude of the total of magnitude force Fy we get 0.03. Okay, thank you.
Assalamualaikum. Today I'm going to talk about the discussion and conclusion of the experiment. So the discussion of the experiment, a vector is usually represented by an arrow, where the direction of the arrow represents the magnitude of the vector in 3 dimensions. A vector direct out of the page or along the positive z-axis is represented by a circle with a dot inside it. And a vector direct into the page or along the negative z-axis is represented by a circle with an X inside it. Carry on with the conclusion of the experiment. The magnitude and direction of the resultant observable forces acting on an object was successfully determined using graphical addition methods. It was also proven using a force table that the resultant net force acting on an object at equilibrium is 0. So thank you for all today.